Okay, now we're going to have some fun. Now we're going to use the limit definition to find the first and the second derivative of a function f of x equals x squared minus 3x. We'll do this in two steps. We start with step number one, find f prime of x. Well, we have our limit definition. F prime of x equals a limit as h approaches 0 of f evaluated at x plus h minus f evaluated at x over h. For this function f, that means it is equal to the limit of bracket x plus h squared minus 3 times x plus h close bracket minus bracket x squared minus 3x over h. See, that's f of x plus h minus f of x on the top. Well, we simplify that and we get the limit of x squared plus 2hx plus h squared, that's from foiling x plus h, minus 3x minus 3h minus x squared plus 3x. We distributed all the negative signs all over h. A bunch of things cancel out and we get the limit of 2hx plus h squared minus 3h over h. We can factor an h out of the numerator. It gives us a limit of h times 2x plus h minus 3 over h. Cancel the h's. We get the limit as h approaches 0 of 2x plus h minus 3. We can do a direct substitution because this is a polynomial. We get 2x minus 3. Thus, we found that the derivative f prime of x is equal to 2x minus 3. Now, this is a function of x, you'll notice, because it contains an x. It's not a number, it contains an x. So we're allowed to do step 2, take another derivative. We're going to find f double prime of x. By the limit definition, f double prime of x is equal to the limit as h approaches 0 of f prime of x plus h minus f prime of x over h. Those are double primes. Those are errors. That should be f prime of x plus h minus f prime of x. So please make that correction. That's equal to the limit of bracket 2 times x plus h minus 3. You see, we're using this function that we just found in step 1, minus 2x minus 3 over h, which is the limit of 2x plus 2h minus 3 minus 2x plus 3 over h. We cancel some terms, and we get the limit as h approaches 0 of 2h over h, which is the limit of 2. Oh, the limit of a constant number? That's just the constant number, 2. That's a limit law. Therefore, we have just found that the second derivative, f double prime of x, is equal to 2 for this function. You'll notice that this time we did not get a function of x like we did in step 1. This time we got the constant function. And okay, that happens sometimes. It's still considered a function. Sometimes you'll get a function that contains the x. Sometimes you'll get the constant function. But we didn't do anything different. It's just in this second step, things got dissolved. They dissolved down to just a constant.